We can start off with the questions that we had in our minds and about like whatever we had encountered during the.
Listen, it's literally ask me anything, meaning you guys are supposed to do the asking. We are supposed to do the responding, right? So this is your chance to bully us.
Can I ask a follow-up about the TA question, Mark? So I'm an undergrad, so I'm taking 485, which means I don't get to do a project even like that. If 1 year later, if I want to be a TA, is that possible?
Well, Auntie's an undergrad, David's an undergrad.
Okay.
Right.
So
and
you get to do your project with your students that you're TAing.
So this is the second time David's actually TAing the course. And I've had sophomores who have TA'd 785.
Wow.
I mean, you have to understand the CMU undergrads are a special category of undergrad. You kids are, and I don't mean this. I'm not exaggerating, right? We are pretty picky in who we pick, who we take. So the kids are ridiculously smart, and I don't mean to put down the graduate students, but our undergrads are smarter than our graduate students. So we've had freshmen. We have a bunch of we have a bunch of sophomores taking the course right now, who are actually doing projects, right? We have and one of the times when we did this, we had I was not here, so Professor Jim Baker ran the course. We had a small class of 15 students, 10 of who were undergrads, and 7 of them went off to start off companies based on deep learning, and many of them went on to TA IDL later. So just to give you an idea, right? Being an undergrad is not any kind of a handicap. It just means that you guys come in with a little more background than the graduate students do, who come from diverse places. So many of them don't have quite the background that our undergrads do.
Peer pressure.
Yeah, right. Absolutely.
I mean, like, we can just go ahead and get started with the first question. Wait, why is this not working? Yeah. So this is for Bhiksha. And I think like everyone else, what did we do differently as a group to prepare for an online semester?
So I want to roll this over to the students. What was your expectation in terms of an online semester? How did you expect things would be different? Anyone?
That the classes would be recorded.
That, of course, classes would be recorded. So we've always been recording the class, right? But in terms of experience, classroom experience, did you?
Maybe like I expected a little less like student interaction, because in class it's much easier to like just speak up.
Yeah, and so we sort of made all kinds of assumptions. We were not sure how things would go. One thing was pretty evident, that you kids would not be seeing each other, right? And although CMU and most of the faculty are pretty darn good at what we do, and we take a lot of effort put a lot of effort in our teaching, at the end of the day, you don't really learn from us. You learn from each other. I mean, if you go back and think about it, 4 years from now, you'll realize that it wasn't your classroom interactions that instructed you, it was your peers. And that is gone this semester. Pretty much you have no peer interaction, which is why, we have like 18,000 posts on Piazza, whereas typically at this time of the year, it's closer to 8. So so we put in a lot of effort in trying to sort of simplify the material without losing content. B, try to sort of structure it such that there was a lot more interaction between us and the students, and between the students themselves, which is why we started off by creating study groups. Even we had planned all of this out even during the summer. We started off by figuring out how the TAs were going to be mentoring the study groups, which is why you have Rashmi and other people just writing to each one of you, checking on you. This is part of our planning for summer. Then we redid every single lecture. So the slide decks changed in small and big ways. we prepared for every single lecture. So over the summer, I actually practiced some of the lectures to see how fast I could speak. And so we counted words per minute. That's the level at which we planned. And so I assumed that I could do between 100 and 120 words per minute, which is slower than the standard class, which is closer to 150. We made scripts. We wrote down what we were going to say to the last word, and did this for about 20 of the lectures. I wrote 150,000 words of notes over summer. My RSI kicked in and my shoulders fell off. And the homeworks were redone. So usually our homeworks are a little more casual. We decided to make things a little more involved this time, with the intention that this would sort of suck you into the course and force you to begin interacting with people and the TAs early rather than later. And a lot went in. And truth be told, things didn't actually work out the way we planned. It just never did. I mean, even the lectures, I was assuming I could speak 8,000 words in 18 minutes. No, I can barely do 5, because there's the interaction, there's the pausing, there's trying to figure out student response, which is why we keep sliding, in our schedule. Lots happened.
Oh, we can hear you.
Was there a question?
No, I just said that we can hear you. So
Yeah, I don't know. That was the long and the short answer there. This is a very quiet Ama, right? Anyways.
So, besides the student interaction,
I'm sorry. Go ahead. Go ahead.
besides the student interaction, do you think that we are missing out on some experience that we would
A
have?
lot. To be absolutely honest, you're missing a lot, right? It's not just the interaction with your peers. So there is the entire atmosphere at CMU. CMU's atmosphere is very intellectual.
Yes.
I mean, you're going to see kids wandering in the corridors and discussing, and what they are discussing with each other is not merely, it boils down to student interaction interpersonal interaction at some level, but the kinds of, it's a campus of geeks. Everybody is a geek. And there's this, and just the level of discussion that you're exposed to in the corridors, even if you're not participating, if you're only eavesdropping, if you're only listening to the side, the things that you see on the bulletin boards, the things that are happening around you, pretty much everything, the entire experience is an intensely intellectual experience in CMU, and you're missing that. So, even the dunces amongst us, and I must say that when you speak of a dunce in CMU, you're really speaking of somebody who's well above average in most other places. Even the duncest amongst us end up learning a lot without putting in too much effort, simply because it's there in the atmosphere, and that is being missed. It's kind of tragic. I mean, think of my own office. If you, during the semester, if you came to my office at any time of the day or night, you're going to find people there, even if I am not there. So that's how it is. The doors are open, students walk in at any given time. There are 5 or 6 students. If I'm not there, students congregate there and becomes, they're having their own little gossip. I went away for 3 months, and they used my place my office as a place to sit down and code, and I came back and found it full of pizza boxes. So that's the kind of thing that you're not going to find when you're isolated.
And I would like to point out to some fun aspects which you would see in a normal semester. And one of them is Bhiksha really used to pass on a sheet to everyone in the class on the first lecture day to write your names and create this name tag. And he would call out to students during the class lecture times to make them stand up and answer questions. Right now, it's more of a voluntary work. He asks if anyone is understanding, or if anyone has questions about the concepts that are being taught. But it was a really scary situation when he used to pinpoint to any one of us, and we used to be scared and always ready and jumpy on our seats to just wondering when Bhiksha would point out to us and ask questions. That's one thing that you're definitely missing out on, and it's a lot of fun. The other thing is the office hours and the way that it happens right now is a very civilized way. I have seen students having verbal arguments about who came first in the line when there was like an in-person office hours, because you can imagine it's the same kind of crowd which still accumulates during each office hours. So, and it was like a very pathetic situation to recognize like who came first. So I think like right now we're doing it in a much more civilized way. That's like the fun part of like what you're missing out on.
Yeah. But then again, in the office hours, you get the advantage that you can answer one person. In a typical office hour, what would happen is we'd have a room, there'd be 20 people who'd come in, 2 people would ask questions, the others are just hangers on, listening to the question answers. And they get their information without ever opening their mouth. That's something that can't happen now.
Bhiksha, we have a question in the chat, and someone recognized those sword you used to use to point out stuff in your PPT. So what is the word for the sword that was used? Is that the question?
No, what was the sword for? The sword. Okay, no, I sort of, it's the way the classroom is set up, it's really hard for me to point out things on the screen. I could use a laser pointer, but then, half the class was watching the streaming, and then a significant portion of the class would go back and watch the videos later. And if I'm pointing at the screen with a laser pointer, that simply doesn't register on the camera. So I needed something really solid, a big, long pointer. And I just happen to have this plastic sword lying around in my office. It's a great pointer. So that's why that sword is used. It's also a nice prop. Sometimes people come to the lecture not because they want to learn anything, but because they want to see the sword.
Okay, so we can like move ahead and like talk about other questions. What is like the high level significance of each homework that we are trying to create, and what are some of the key pointers that we expect the students to learn from each homework, or any homework for that matter? The students can like jump in and specify if there's one particular homework you want to talk about.
So the homework set is designed with 2 things in mind from the very beginning. We want you people, so there are 2 parts to every homework, as you've seen. We want you people to understand the underlying concepts. So you are never going to understand the underlying concepts by simply using a toolkit. There are any number of you who've actually gone through Coursera and other courses, and you can implement a deep learning system end to end without knowing what goes on inside. And so the part 1 of the homeworks, and also the quizzes for that reason, for that matter, they are designed to sort of ensure, or at least try to ensure, that you understand the innards of the system. And we sort of pride ourselves on the fact that when the course is done, each one of you is technically, if you've gone through all of the homeworks, you're technically capable of writing your own toolkit because you understood the whole thing end to end. And so that's what the part 1s are supposed to be doing. The part 2, simply being able to write the low-level nitty-gritty stuff is not enough, right? You still have to know how to build large, complex systems. And so our part 2s are big problems. I mean, you're working with hundreds of hours of data, you're solving a big problem. The performances that you're supposed to get in each of these problems are pretty close to state of the art on multiple tasks of different categories, of different complexity. So and again, this is an intro course, so we don't take you all the way through more complex tasks. We won't have time. We stop with sequence to sequence models. But the point is, by the end of this, we've sort of addressed both the low end and the high end side of implementing and working with deep learning systems. And that is really the objective behind these homeworks. And each one of the quiz questions, if you will actually go back and look at the quizzes, every single quiz question, except the ones that are based on readings, where we try to force you to read something, has a concept that it's invoking, right? It's a concept that actually eventually applies to practical problems. Why is my network not training? Why is my recurrent network forgetting to keep track of things? Why is my convolutional neural network not detecting a pattern? What is the difference between this kind of structure and that kind of structure? So the quiz questions are designed to invoke specific concepts. And except for an odd question here and there, pretty much every question there has an underlying point, which is supposed to be instructive. So the design end to end was meant to instruct. Anybody with a question there? Yeah.
I know. I was just saying, like, if any TA wants to add anything up.
Yeah. Okay, so Chiun has a problem, has a question here, right? A very good question. So our homework 1 was out of sync this time around. And again, this is just us trying to, realign everything for the online semester, because what typically happens is what you did in homework 1 this time is what ends up being done, not in exactly the same format, but a very similar format for homework 3. But given the constraints of the online semester, we figured that people are going to be a lot more enthusiastic and energetic at the beginning of the semester. So we give you we sort of front load the most complex task up front. Now, what was the point of the homework? The point of the homework was just to show you that regardless of the kind of function that you're trying to, that you've got, the kind of, however complex it might be, and regardless of how much data it works on, what it finally computes, it's differentiable. And so, and we also wanted to show you people that the differentiability of the functions, when you go through your, go through calculus in high school and college, these things are made to look extremely tough. Your typical high school problem gives you this horrible little function with 3 or 4 terms, with something inside something being exponentiated to something, and then you're supposed to compute the derivative. And then, you write 3 pages of nonsense on your answer sheet and get a 0. Now, this is, whereas if you actually went and coded that function in, then you could just work your way backwards and compute the derivatives with respect to every single component of the function, regardless of the complexity of the function. And this is something that tends to get lost when we simply sort of blindly work with derivatives and focus on the math of it. So homework 1 was supposed to expose to you the fact that computing derivatives is not magic, right? There's no fancy math to it in reality. It's a very computational thing. And once you know that, then I can keep throwing increasingly complex neural networks at you, but you are never going to worry about how do I optimize this, because you know that at the end of the day, it's just a function. You can compute its derivative. And so that was the point of that first homework. And in fact, some of our TAs have gone on to find that this autograd setup applies in other problems outside of DL, because it's a generic framework for computing derivatives, right? And so it actually has applicability in the general domain of machine learning, but outside machine learning of various other problems. Anywhere you need calculus, you can just use your homework 1.
Yeah, on that note, I actually, for convex optimization, I actually ended up using MyTorch for some of the problems, because I wanted to understand like how certain derivatives are calculated, especially because matrix calc can get a little complicated. And so I basically, I basically like traced through, like I implemented a problem in like AutoGrad, and then I traced through like what computations went to what computations, and then I converted it all to symbolic calculus. And then after I did that, I got full points for whatever I was doing. And so it's genuinely a useful tool if you guys want to use it in the future. But yeah.
Yeah.
I think like this is a good time to talk about how this class is relevant for, like future opportunities. And I guess like we have decided that we'll talk about industry experience and as well as research experience. So Jacob, do you want to like get started with it?
Yeah, I could do. Yeah, so I took DL in last spring, so spring of 2020, and then during that time I was also recruiting for internships and stuff, and so the place that I applied to and then I eventually interned in, it's the Bosch Center for AI, so it's in Pittsburgh, And so basically they were looking for students who had taken the IDL course here, because they were like, there's a particular reason, you know, Bosch AI is in Pittsburgh. And so when I did interview with them, we basically talked about some of the course content. We talked about the projects that I worked on. Also, like, sort of quizzed me on my knowledge of the like deep learning problems and also related problems. And then basically that's kind of how I got the internship. And so I can pretty tightly attribute IDL to being sort of like a big contributor to that. And sort of the projects that we worked on, it's basically computer vision related. And so it was basically in retail stores, there's already like a network of security cameras. And so what this product was it was basically like a sort of a software overlay onto it. And so we'd use computer vision to track where customers were in the stores. Like it was all completely anonymized. So it wasn't like creepy in any sort of way, but it was like just their trajectories and their locations and like how long they were spending in front of certain displays and things like that. And so a lot of the work that I did was on the trajectories generated from the models, as well as like modifying the model and tuning it so we can get improved trajectories, and then generating analytics through that. And so if you're interested in like the kind of work that like you read a lot of research papers, you tune some pretty complex models, like you're doing a lot of cutting edge stuff, because as far as I know, there still aren't a lot of competitors for that product yet. And so it's a pretty exciting sort of field. So yeah, if you're into that kind of stuff, I recommend Bosch, but also like a lot of R&D in tech in general is pretty exciting. So,
but actually, in terms of industry opportunities, it turns out that a very large number of students who've taken our course have found jobs basically based on IDEA. I mean, directly attributable to IDEA. For example, only last week, I was speaking to a student from 2 semesters ago who's now heading the AI analytics for the University of Virginia hospital system in West Virginia. So University of West Virginia. There are 12 hospitals. They collect tons of data, and they're supposed to analyze this data and make predictions about who's going to get insurance, who's going to come back and get sick, and all kinds of other things. And the person who's currently in charge of that project, she actually wanted to come back and collaborate with IDEAL because she thought she could get some project teams from us. She really had no background in machine learning or deep learning. She's not even a computer science or an electrical engineering graduate. But then she took the IDEAL course, and basically her entire sales pitch to the hospital system was based on what she did in IDEAL. We have other groups. Right now, there's at least one company in Pittsburgh and 2 companies in the Silicon Valley, which were started by IDEAL students based only on the work they've done for the course. We've had, I must say at this point, several hundred students who got jobs and internships based on their fairly intimate knowledge with deep learning. So one of the things that happens is that you guys get thrown off the deep end. You have to work with fairly complex things. When you're competing with each other on Kaggle, that's real. That's not, a toy problem that you're working with. You're really struggling with a real problem. At the end of the day, you know how to deal with big problems. I mean, the actual problems you'll deal with in industry are even bigger, but at the end of the day, you know how to deal with big problems. And that's an invaluable skill. And it turns out that a lot of these guys are looking for it. And matter of fact, when we have these career fairs in CMU, most students will actually explicitly list IDEAL on their resume. And I know that that the recruiters from Apple, Facebook, Amazon, they actually look at that. And because I speak to some of these guys. So in that sense, it opens up a lot of industry opportunities beyond even research.
I can add one sentence to it, and it's about NVIDIA. Like, I think I qualified just for NVIDIA's rules because I took deep learning. Like, they sort of require, because it's right now making everything is deep learning for them. And if you want to be a deep learning engineer, This course is just like a certification that you are qualified for that particular role. They look for something else also, but this is the first big step that you can take. And generally in all the career fairs, NVIDIA will have like a huge line for the deep learning role, and you will see all the students who have taken deep learning are in that line. It's like a norm in every career fair here at CMU.
Yeah.
And I think like I would like to add, this is more from like a TA perspective. After I added on my LinkedIn that I'm a TA for the deep learning class, there were like many requests coming in from the recruiters themselves and in mails about like if I want a job in deep learning. So if you are like TA in deep learning next semester, you know the opportunities that are coming in your way.
Yeah, so that's something. I've had folks in Oculus and a couple of other companies ask me for my list of TAs. So, but I'm not selling TA-ship. I'm saying, we're answering questions, but yeah.
Yeah, so I guess like we covered the industrial setup and like how the opportunities in industries pan out after you're taking this class. So let's hear from Angjian, who's doing research in deep learning right now after taking this class, and what does he have to say about it? Angjian, are you around?
Yes. Yes. Can I share my screen? Oh,
I'd actually like some questions from the students. They're awfully quiet. Anyway, go ahead.
Yeah, after this we'll take questions from the students.
okay. So I will talk um share some feedbacks of taking this course. So I cannot do research without this course. In the last semester, I did this course and I learned a bunch of stuffs, which really helped me to develop my interest in deep learning research. And current semester, I'm still taking some more advanced deep learning courses, and I have some course projects. I think taking this course enable me to thinking abstractly. So it's like we are using more deep learning techniques to model language or model the visual images. So now I want to combine them together, and currently I'm working on multimodal deep learning. So one instance of this kind of problem is visual question answering. Can I share my screen?
Yeah,
Uh,
sharing.
Okay, I think, yeah, I'm sharing now. So I'm now working on this data set. It's created from Carnegie Mellon University.
I don't think you're sharing it yet. Just one sec. Yeah, go ahead.
Oh, can you see my screen now? Can
Yeah.
you see? Okay. So I'm currently working on this data set. It's VQA corresponds to visual question answering. So the task for this problem is that given an image and a question, what's the answers? So for example, we can ask some questions to this question. What is singles or double tennis? The answer is singles. So the answer, you cannot answer this question just based solely on one modality, visual or question. So if you are not taking this course, it's impossible or it's impossible for you to find the correct way to address this problem. But after taking this course, question could be, I want to annotate. Yeah, I find Zoom annotation is really helpful for me to illustrate this. Okay, so after taking this course, the question part is nothing but something like an embedding. You can use some black box magics in deep learning methods. You name it. You can use LSTM, BERT, transformer, whatever. You can generate an embedding for this language modality. For visual modality, also you can use whatever talking technologies like RCNN or ResNet, you name it. So you can just treat them as some black box magics. The input is image and the output is just an embedding. So we can just treat this as image information. Sorry, series. You can just treat this as image informations and treat this language as language informations, and you somehow combine them together to generate the answer. So how to generate the answer is still a very hard problem, but we have some fusion methods like attention or other methods So say now we are using attention and also there are a bunch of attention techniques. You can use whatever attention metrics you want in order to boost the performance. So before taking this course, it's if you only take like machine learning, introduction to machine learning. So if you only know how to classify the tags or classify some supervised you use some supervised do some supervised machine learning problem, it's not possible for you to tackle this problem. But after taking deep learning courses, you know how to tackle this problem. And more, I want to, so personally in this course, in this project, I want to know more. This visual question answering cannot be answered without external knowledge. For example, this is knowledge-based visual question answering. This means that you cannot solely based on the image or language to answer this question. You have to use some common knowledge to answer this question. So in this question, tennis, this is a common knowledge. It is the computer does not know the concept for tennis. You have to extract external knowledge from some knowledge base. So now we have another modality which is knowledge base. So I model this knowledge base as knowledge graph. Somehow we have to incorporate this knowledge graph to with the visual part and combined with the language part, use the three modalities to generate the answer. This is extremely hard. The state of the series again, because current state of the art performance. So I will say in this data set, the current state of the art accuracy. So accuracy is only 27% because he does not, this dataset does not provide external knowledges because you as a human, you have your brains, your brains contains a lot of common sense knowledges. What is tennis? You learn throughout your life. However, computer does not know this. You have to provide external knowledge to them. But how to fuse this external knowledge with the visual and language is a very hard problem. And you cannot address this without without taking this course. Okay, I'm advertising this. I'm advertising this course. So another technology you will not learn in this course is graph neural network. So you learn CNN, which is designed for image. RN, which is designed for language sequence input, but you don't know how to address graph data. And so graph neural network is another technology used to embed the graph knowledges, graph types of graph structure data. So I learned this by myself to embed in order to tackle this problem. But I think the prerequisite for learning graph neural network is that you have to know convolutional neural network and RN. So taking this course really provides me a bunch of tools and knowledges that is needed to address the future problems in the research. Yes, that's all.
Thank you.
Yeah.
That was like an excellent pitch for this course. I think like we should take student questions now. We had someone in the chat asking if they can speak. So
actually, I have a question for Professor Piksha.
Mhm.
So, for now, like the deep learning technique is dominating the industry. I'm wondering, what's your attitude about the deep learning, the future of deep learning? Because after taking like the introduction courses of this course, I have such an intuition that if the condition permits, the deep learning actually can learn anything. As long as the network is big enough.
With data, I mean.
Yeah.
Yeah, I wish I had an answer to this thing, right? So I've been around long enough to have run into the latest answer to life, the universe, and everything every 3 years, and that keeps changing with time. So computational learning theory was going to be the big thing. HMMs are going to be and time series models were going to be the big thing in the early 90s. Computational learning theory and support vector machines and all of those things were going to be the big thing. We ran into other more interesting models later. There's always a flavor of the day. So, and that has been changing every year. There's something different about deep learning systems in that that deep learning as a technology has sort of persisted for almost 10 years at this point. So, and it doesn't seem like it's vanishing anytime soon. So I suspect that it's here for the long term. Now, you're right that it's in principle it can learn anything, but what is it you're really doing over here? If you strip away all of the fancy analogy to the brain, blah blah blah, you name it, all that you really have is a very cool way of optimizing any odd function using gradient descent. In fact, if I had to summarize the entire semester's worth of lessons into one little statement, one little topic, homework 1 part 1 with your autograd was your entire course, pretty much, right? Because what you found is that so long as you can compose a function using smaller functions, it doesn't matter how complex it is, you can optimize it to learn any odd input-output relationship. That is really the bottom line. The rest of it is all about different ways of composing these functions, but then you don't really want to be bottled into thinking that the specific things you're seeing in the course are the only way of composing these functions. There are and that's what the research researchers are finding. If you go and look at the latest neural network models, they're calling it neural networks. There's nothing neural about it, although there is a certain amount of network. So what we have learned through all of this is that you can go ahead and be brave and compose arbitrarily complex models. And we are providing some way of trying to fit that model to some given data. Whether it will generalize or not is something that can be investigated, right? And so the meta lessons over here is that is not that there's anything specific about neural networks. It has to do with the fact that if you compose complex systems from smaller, simpler systems, those can be complex functions from smaller, simpler functions, then those can be optimized to learn specific input-output relationships using standard gradient descent. That's really the entire story in a nutshell. And seen from that perspective, it's fully reasonable to assume that something like that can learn any relationship at all. The problem here is that the amount of how do you formulate these things? Are we ever going to consider a simple thing like learning a grammar, right? I could write down a bunch of grammar rules in a piece of paper, on a page of paper, and somebody who's familiar with the notion of grammar can see those and can make all kinds of interpretations about that grammar. And somebody who knows about the structure of grammar can figure out how to learn these grammar rules from data, so long as you know the structure. But if you start from scratch, from absolutely nothing, and if all you're trying to do is to figure out the relationships in some data, you're never going to learn it. So for example, simply by looking at very large amounts of data, it's highly unlikely that you will actually learn the simple multiplication relationship. If I keep giving you AB, and then I ask you to A and B and ask you to predict C, right? Where C is the product of the two. And I ask you to learn a function which captures this relationship. Unless you know the structure of the multiplication relationship, you're not even going to learn something that simple, right? So there's this, there's a certain degree of human intelligence that goes into formulating the problem. But if you get past that, then yes, you can learn pretty much anything. The real challenge seems to be backing off into how do you formulate the problem.
Okay.
I don't know if I answered your question. Right.
Yeah. Okay. So just a quick follow-up. Do we have any chance to see you bring the sword to the class in the?
How are you going to see it?
Maybe hang up on the wall behind you.
You can't see it. I don't. Maybe I have a sword over here. My sword's in my office. What I can do is wear a wig. I wore that last semester, 2 semesters ago.
Yeah. Okay. I have no more question.
So we have a Halloween tradition. I usually wear something funny on a Halloween, but that's not going to show up on Piazza.
But that can happen on Monday's lecture, right?
It's past Halloween, isn't it? Tomorrow is Halloween.
Yeah, so that's why it's extended.
Yeah, I need a wig on Mondays. On Monday, I can wear a wig on Monday.
So are there any other questions at this time?
Yeah, I have a question. So like deep learning nowadays has wild application in different fields like healthcare, gaming, stock market, and etc. So like what is the most promising interdisciplinary field that the deep learning has application to? So like the most promising and popular field.
So it depends on what what your objectives are, right? If you're into making money, then it's the financial market. Pretty much every investment firm these days has a research team who's building deep learning models to predict the market tomorrow, so they can make money off it. But if you're into the bigger picture, the immediate short term, in terms of return on investment to society, in the immediate short term, I think the best directions are in general direction of healthcare, where it's not merely about predicting disease, it's not merely about diagnosis, it's about the bigger picture, the management, right? Is this patient going to come back? What one of the biggest problems we have, for example, is to predict how many doctors should man the hospitals tomorrow. You have a limited number of doctors and a limited number of hospitals, and the doctors, and you can't have them all be at the hospital all the time. They will die, right? They need their downtime too. And at the same time, you expect to see more people in the ER at certain times. You expect to see more people in other kinds of places at other times. So simply redistributing an optimal distribution of resources is a huge problem in healthcare. That's something, right? Things like in the insurance. So they have to make predictions about how much money is this going to cost, how am I going to reallocate my finances just to make sure that everybody gets the best treatment that they can get. Again, that comes under healthcare, but it's not really medicine, right? So the healthcare industry is probably going to be the biggest beneficiary of AI in the immediate term. But if you go beyond that, I think you're going to see a even bigger beneficiary in governance, because it's all about optimization at the end of the day, right? Prediction and optimization, and just knowing how you reallocate your resources, how you're going to handle issues, how you're going to handle things as complex as international relationships. All of these are working on human heuristics these days, right? And that can and a great deal of these human heuristics are based on abstract theory and formulae that people have. I mean, that have been codified into textbooks, but really are better off dealt with using what is learned from data, right? So I expect that's where we will see the next big wave. But somewhere along the way, people are going to keep finding ways of scalping other people and making money using AI.
Yeah, I have another question. So like I am personally interested in NLP and the recommender system. So what courses should I take for the next semester?
So you TAs, you guys can reply.
Oh, I have one suggestion. Machine learning for text mining. Yes, but it's not deep learning courses. It's I suggest it because it covers topics in recommendation system. But I think it's doing recommendation system in a very traditional way. It's not. I doubt there is a very advanced deep learning method.
So yeah, We have lots of really nice courses in LTI at least. Multimedia, multimodal machine learning for text mining. There are other new courses that are being proposed, which will probably come up in 2 semesters from now. The faculty keep updating their course catalog. The issue is that almost every course is going to be slightly passé in that the research community is always 2 steps ahead of the academic teaching community. That's the way it is, right? You can't begin teaching a course till it's sufficiently solidified, till the topic is sufficiently solidified. So you should really be thinking of the courses as something that give you the basis to go off and jump into the bigger research, topics and research.
Yeah, thank you.
Yeah.
In the topic of courses, so ideal is a really good balance between the theory and research aspects and the practical aspect, like especially with P2s and the data sets that we play with. In the advanced courses that I saw, at least till now, most of them are like advanced deep learning is actually advanced theoretical deep learning or more towards the research aspects. But what about the practical aspect, like few shot learning is something that's coming up, distributed training, model quantization, that's very popular because you want to run models faster on phones and stuff. So is there anywhere we can go to learn about these aspects of
So at this point, there really isn't. I mean, that's really a course that's waiting to be, done. The problem with courses of that kind is that it's a very flavor of the day kind of thing, right? What is hot today and what is relatively important today is not going to be important tomorrow. So to give you an idea, we did a bunch of work a few years ago on compacting models. For instance, there was a paper that we showed, for example, that you can reduce the amount of communication in a neural network by a factor of 10, that you can, we showed that you can quantize networks and come up with algorithms which learn quantized parameters and make them really small. You spend a certain amount of time and effort on it, a couple of years, a graduate student wastes his master's. And then the next thing that happens, NVIDIA comes out with its next card. It's cheaper, consumes less power than your integer processor. Why did I spend my time on all of that, right? So there's a certain risk to starting courses on the flavor of the day topics, which is why although there is enough expertise, there's a reluctance to doing that. Somebody has to invest. I mean, running a TIC course is a lot of investment in time and effort. To one lecture takes about a week to prepare if you do it well. That means preparing a 26 lectures is half a year's work, just preparing the lectures, right? Stop and think about that. In that half a year, the industry has moved on. So there's a reason you actually don't see a lot of these flavor of the day topics come up as courses. There's definitely a need for it. And my personal bias is to have student run courses for these topics of this kind, but no students have volunteered. Yeah.
Yeah, I mean, like, sorry, sorry, just hold on to your question. So there's a course which is 15688. It's taken by Zico Coulter. It's called Practical Data Science. Now, this is not deep learning. But he tries to cover everything from like the start of machine learning to like there's like one assignment in deep learning, and he goes through like NLP, collaborative filtering, recommendation systems, and he does like a lot of like how do you say it, like practical approach to it. So it's like the problem sets are very real. You will have like very real data sets and you work through it. The only problem with this course is he's not consistent with it. So I took it in fall 2019, but he did not offer this class in fall 2020. So I have no idea if he's going to like do it in spring 21 or.
Yeah, again, so this is one of those, flavor of the day courses in the sense that it's a totally valid course, but simply keeping up with the times is so hard that sometimes the faculty get fatigued. Right. So Chin, you had a question?
Yeah, I just want to like add on and then like hop on this thread. I also took practical data science at the same time you did. That was before I took intro to machine learning, and then I was super confused about everything. But I managed to like get through all the homeworks and all that, because there's a TA carrying 200 people on his back. nice person.
Yeah,
Care of.
that class.
Oh, like so good, but it's like 200 students. I mean, technically,
One TA?
other TA doesn't really do it.
Yeah.
Sorry, it's on record. I'm so sorry, but like,
It's recorded.
yeah, that class is good. Also, if you like distributed system, this semester I'm taking a class by Heather Miller. So she's a prof in CS. The class is 17700 or 7400 depending on if you're undergrad or grad, and it's called Large Scale Data Science and Machine Learning. It uses PySpark, which is a version of Spark, and then it uses TensorFlow, and the workload is definitely less than this class. Glad for that. But if you're looking for like, I guess, like if you just want to learn how to use Spark, they're pretty beginner friendly. They also like do their notebooks on Databricks, which is really easy to use, much easier than GPUs, easy to access.
On Databricks.
But yeah, if you're interested, you can check out that class. I think they just started this semester. Yeah, and then she's a cool person with a dog in her house.
She's got a dog in her house.
Yes, it barks.
Yeah, because on Zoom it matters, right? Yeah. I should get like a puppy over here to keep bouncing around.
But yeah, like she's a like knowledgeable person.
Do you have any pets, Professor?
Me, not anymore. Just you kids.
And I was also curious about how you manage your time, because I see you're also online on the weekend answering questions like along with the TAs and stuff.
I don't have a life. It's very easy, right? I don't manage my time. I wish I could say I manage my time. This is I bought myself a collection of comics because at this point, my brain is so fried. The only thing I can absorb is a comic. It's all nice in pictures, and you have one little blob, and there's only 3 characters in it. And I haven't managed to get through my comics in 6 months. So actually, that's not true. I managed to read a book a week or something. I keep trying simply because it's good discipline. But anyway, because it's fun. But managing time is really hard. And one of the things that has happened is, particularly this semester, in other semesters, not when you have on classes and in-person classes, it's not so bad. I've just sort of resigned myself to the fact that Mondays through Fridays, 9 a.m. to 7 p.m. my time belongs to the students. But 7 p.m. I come home, and it's not that I am unwilling to interact with students. Students are unwilling to interact with me, which is nice. So I get 48 hours off. That has kind of disappeared. Now you have kids sitting in China, and I got to talk to them at midnight. I got kids sitting in India. It's like 2 a.m. There's Sundays because they can't find times at other times. Saturdays because they can't find times at other times. This semester has been totally shut. Time management has not happened. I don't know how the TAs are managing.
I mean,
so
like
Rashmi is a specialty, right? She only sleeps 15 minutes at a time, and so and I think she does it sitting or something, and that's why you see her online all the time.
Like a shark, like one hemisphere of the brain is sleeping at a time, the other one's awake.
Exactly, something like that. I don't know how the rest of you kids do it.
I think like no one of us is like really sleeping, and that brings me to like one of the questions we had about like how much work is it to like TA this course, and what was some of the takeaways that we as TAs had in the last 2 months. So I will definitely speak about it, but does any other TA want to start with the takeaways as TAs that we had while doing this course, like while taking this course?
Yeah, I don't know. TAs can answer that.
I think like you really do get as much out of it that you put into it, in the sense that like when I help with the homeworks or when I answer questions on Piazza and stuff, like you end up really learning a lot just in the process of doing that. Because you not only have to be able to like understand it and be able to execute it yourself, like you have to be able to explain it in an intuitive and graspable way to other people. And that really requires like understanding all the edge cases, because you get like 100,000 questions that you like kind of never anticipated people would ask. And so that means like from pretty much every angle of the topic, you need to understand it pretty well. Otherwise people poke tiny holes in it and you'll eventually like have a sinking ship. And so I think understanding things really well has been like sort of a really nice part of the TA ship.
Yeah. But I honestly don't know how the TAs have managed to keep up there, keep up with things. That's it's tough. And they actually have it tougher than me. I'm the teacher, right? I don't have to do the homework. These guys are both students and instructors. They're doing other homeworks while they're teaching this set. And I have no idea where. But my theory is that when you sign up as a TA for deep learning, you magically get a 24 extra hours in every day and you fill them up.
I think like my biggest takeaway from like taking this course, one, after you go through like several errors or like you try to debug a lot of code, at one point you'll reach that level where you'll just look at the error and you'll know that like this is where it's going wrong. And I think like that helps, and that is like a good learning experience for me as well. Like now I can like translate it for like my own research work or whatever, like like where things go wrong. So like that's one of the main things that happens when you like try to debug someone else's code. And the other thing that I realized, and this is especially true for like a online semester that we are having right now with very minimal in-person interaction, you have to play both like a good cop and a bad cop, because there would be times when you have to be like very how do I say this, like you have to be lenient, but you also should know like where you have to start being strict. And like having like a diversity in your team or like in the entire team where like some TAs are strict and some TAs are like lenient really plays out well. And I guess like that's happening in our team. There are certain TAs who are strict, there are certain TAs who are lenient. Viksha himself is like very, very lenient. He's like very nice to everyone, give them all the time they need, let them do all the homework so that they, like they just like learn everything. That's our main motto. And I think like when you guys become TAs, like you will have to like discover that dynamic within yourselves, I guess, like if I'm putting it the right way, and just like realize who's going to be like the stricter one and who's going to be the you need a balance of both. There would be times you take a difference of opinions to actually make sure things work in this class. And I guess like that was my biggest takeaway from this class.
Yeah.
I don't know. Like other TAs were like not willing to speak, and I have no idea why. Mansi?
You good?
Yeah.
Hi. What? Are we talking about what we feel about TAing?
Yeah, and you are an experienced one, so you should be going about like how did you?
Oh yeah, David's been done this twice.
Yeah, this is my second semester. I think I'll end up echoing a lot of the general sentiments that other people have said, but it's nice because I decided to take the course because this course has done a tremendous amount for me because it's the one that really got me into deep learning, and then two, I thought that the TAs of my semester went out of their way to like help people, and I thought that was really admirable. So I try to be a TA as well. And I guess this goes off what other people are saying, but the TA student interaction is a pretty fun one for the TAs as well, especially when the students really trying to learn the material, or they're stuck on something and they want some like guidance, and you end up helping them out. And I guess not to ramble a little more, but not to ramble too much, but like that's kind of what I like about the course. Past like looking on Piazza, I just like holding off like the office hours set up a lot. That's my favorite part about TAing. I don't think that was the question, but whatever. Actually, I saw that someone had a hand raised from a while ago.
Yeah.
Yeah.
Sharon, do you have a question?
Oh, I think it was for the previous one. I forgot to go over it.
Okay, guys, I gotta go and grab some lunch, considering I haven't had breakfast. So, but if you want to hang around and have fun, go ahead. in general, I am super accessible. So, which means that you can ask me anything. AMA is generally a rule of the day. It's not meant for special occasions. You can post it on Piazza. You can post it on email. It's all very fun, right? So the one thing I don't want students to feel is shy or embarrassed during the course, because shyness and embarrassment are two ways of making sure you never learn anything. And that's one of the reasons, all of us, including the TAs and myself, we go out of our way to try to be approachable and accessible. And we like you to realize that at the end of the day, we make as many mistakes as you guys. So there are no gods in this collection, right? There are just a bunch of humans. Some are older, some are younger. So keeping that in mind, you get one chance to learn. You're not going to get a second chance. Time flies, life just zips by. And the one situation, and what courses do, is to put you in a situation where you feel sort of mentally compelled to go through the process of learning. And so I think you should take advantage of it rather than just let it slide, right? Anyway, I'll take my leave. Thank you, guys.
Thank you.
Bye, everyone. Woo.